All right, let's try example number 2. So again, remember, there's lots of little steps that go into it. The difference with example 1 is the parameters were already given to us. That is not always the case. And you'll find that in this one, because if you look, it says find the area of the region bounded by these graphs, but it doesn't give us 2 vertical lines like the first example did. So there's one extra bit of information you have to do. So what I would suggest is, because you have to sketch it basically. So we'll start off with that. So we have a parabola, which basically, if it's 2 minus x squared, so a parabola normally would start at the origin and go up. That negative flips it, but you have a plus 2 there, so it bumps the parabola up to positive 2 for the y-intercept. And then it opens down. G of x is a linear function that starts at 0, and it goes up 1, over 1, up 1, over 1. So if I connect them, and what you're going to find is, unlike the first one, you do in fact see that you have created a closed region here. The problem is that we don't know what the points are or what the x values are. So these are the things that we have to find. We have to figure out what x values those are. So if you need to get parameters, and parameters are basically the intersection where the two functions, where they meet basically, or where they cross each other. So if you need to get parameters, you set the functions equal to each other. Set functions equal and solve for x. So before we even start the process of integration, we're going to take these two functions, f of x, and set it equal to g of x. So f of x is 2 minus x squared. G of x is x. The x squared is not going to cancel, which means everything has to come to one side. My personal preference is I always like my x squared positive, so I'm going to bring these to this side. So I end up with 0 equals x squared plus x minus 2. You then say to yourself, okay, well, what multiplies to get negative 2 and adds to get a positive 1? That's a positive 2 and a negative 1. And you end up with two x values, negative 2 and positive 1. So that means here should be negative 2, and here should be positive 1. So there's that one extra step that you would have to do if the parameters are not given to you. So when we create our integral, we are going from a to b. Those are our parameters, so make sure you're putting them in order the way they would appear on a number line. Lower number is on the bottom, higher number is on the top. In terms of f of x and g of x, f of x is the function above. So in terms of that shaded region, that would be our parabola, and g of x is the one below. So f of x is our 2 minus x squared minus g of x, which is x, dx. Rewrite it one more time without any of those parentheses. And then when you get it down to that, now you can actually integrate it. So you get 2x minus x to the third over 3 minus x squared over 2. And we're going from negative 2 to positive 1. So now we have to we have two parentheses. One of them you sub 1 in. And if you want to simplify them right off the bat, absolutely do that. So you get negative 4. Then we have negative 2 to the third over 3 minus negative 2 squared over 2. Just be very careful with the values. So you get 2 minus 1/3 minus 1/2. If I distribute this negative, that's a positive 4. Negative 2 to the third, this is negative 8. With a negative makes a positive 8/3. With another negative makes a negative 8/3. Negative 2 to the fourth is 4. 4 divided by 2 is 2, so this is negative 2. But with this negative, now makes a positive 2. And combine whatever like terms, so you're not having to get 6 different terms with a common denominator. So we have 2, 4, and 2, which gets us 8. We have negative 1/3 and negative 8/3, which is negative 9/3, or negative 3, minus 1/2, which gets us 5 minus 1/2. You can get a common denominator of 2 here, and you end up with 9/2 units squared for your final answer. Okay, these are lengthier than typically normal what we've been doing. That's why it's always left until the last part that we have to cover. And typically you never have that many of these to do just because they are time consuming and there are so many steps, and I will be checking for the steps. So just make sure that as you are working on them, you are practicing with the steps itself. All right, last example, I'm gonna just throw a trig in there just so that you can see it. So it says the sine and cosine curves intersect infinitely many times, bounding regions of equal area. We're gonna find the area of one of those regions. So if we graph the sine and the cosine function, so we know we have pi over 2, we have pi. If we use our unit circle, we have 3 pi over 2 and we have 2 pi. So the sine function starts at 0. Amplitude is 1 and -1. Pi over 2 is 1, pi is 0, 3 pi over 2, and 2 pi. So here is our sine function. If I pick a different color for cosine, cosine would start at 1 and basically go the opposite in terms of what they equal. And if I sketch that, I get this. Now we're being asked to get the region of the area of one region. So that would be this guy right here. So we can see that the cosine function is on the bottom, and we can see that the sine function is above in terms of f of x and g of x. The other part that's missing, though, are the parameters. So we have to find the parameters. So that's where you take the two functions, sine of x equals cosine x, and we have to figure out where that's true. Well, on the unit circle, if we're saying that the sine and the cosine are equal to the same thing, that means that we are in quadrant 1 and we are in quadrant 3. And our denominator would have to be a 4. So in those quadrants, we have pi over 4 and we have 5 pi over 4. So that means this is pi over 4 and this would be 5 pi over 4 where they intersect. All right, so area equals, our parameters go from pi over 4 to 5 pi over 4. We said that the sine function was above the cosine function, so sine x minus cosine x dx. When we integrate, the integral of sine is negative cosine. The integral of cosine is just regular sine. And we're evaluating from pi over 4 to 5 pi over 4. So 5 pi over 4 is going to go in first. So we have negative cosine 5 pi over 4 minus the sine of 5 pi over 4. Minus negative cosine pi over 4 minus sine pi over 4. So at 5 pi over 4, both of the values are negative radical 2 over 2. At pi over 4, both the values are positive. Now, you should not get a negative area. That doesn't make sense because obviously we have a region that's shaded, so don't just assume when you see things that are the same that they're going to cancel out. We have lots of double negatives going on here. So if I get rid of all the double negatives and distribute the negative on the second one, you're going to find that you end up with 4 radical 2 over 2, which reduces to 2 radical 2 units.